All right. So basically what I did was for the advanced Lewis dot structures, I took the compounds that we have to make, and I put it into the same worksheet that we did before, so that way it kind of breaks it down a little bit. All right, so first we have N and O. We have to find N. Are you okay there, Jamaria?
I'm so sorry. I totally forgot you're even here. Okay, let me exit. Let me leave.
What?
Because I'm being distracted right now, so this is a bad idea.
Anyways, just like in class, right? All right, so we have N and O in our Lewis dot structures. We need to figure out the number of valence electrons for each of them. How many valence electrons are for nitrogen?
Where's nitrogen? 5.
Oxygen.
6.
Okay, does everybody know where we're getting those numbers from?
Yeah.
All right, so combined, it's 11. But we have a charge here of a +1. So when it's positive, are we taking away electrons or are we adding electrons?
Taking it away.
We're taking it away.
Take it away, Penny.
And electrons. Okay, so we have nitrogen bonded to oxygen. And we have 10 electrons we have to deal with. We have 2 of them put together in this bond here. So this bond right here is 2 of those electrons. How many more do we have left?
8.
We have 8 left.
Hey, what happened?
I erased the green part. So we have 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 electrons there now. So now we have a total of electrons. We have all our electrons accounted for. However, we have an issue here. Take a look at individually. If we look at nitrogen and oxygen separately. So if I take a look at nitrogen here, does nitrogen follow the octet rule?
Yes.
Yes, it does, because it has 6 dots from the lone pairs and it has 2 more from the line. So it has 8 electrons. But if we take a look at oxygen, how many electrons does it have?
4.
It only has 4. So oxygen here does not obey the octet rule. That means that he needs 2 more sets of electrons. He needs 4 more electrons. Does everybody see that?
Yeah.
All right, so what we end up doing is that this lone pair here ends up getting shared, and this lone pair here ends up getting shared. Those where those 2 extra sets come from. So we have nitrogen. That didn't turn out real well. We have nitrogen. Now triple bonded oxygen. You see that? Who does not see that? Anyone? Or are we okay?
Okay.
Yeah.
We're okay.
Okay, all right. So we still have a couple lone pairs to deal with. We still have these 2 lone pairs here. And we still have these 2 lone pairs here. Now if we go back and reanalyze it, how many electrons does nitrogen have?
8.
8, because it has 2, 4, and 6 from the bond, and then 2 more for the lone pair. And if I take a look at oxygen, how many does oxygen have now?
8.
8, 2, 4, 6 from the bond, and another 2 from the lone pair. So because of that, this is going to be the final structure here. Where it's, I'm going to erase all this up here to give me more room. Where it's N triple bonded to oxygen, and that's where that bond's coming from and triple bonds are coming from. That was one of the questions that were brought up earlier today, which is one of the reasons why we ended up having this. So that way we can figure out where those double bonds come from. Are we okay with this one?
Yeah.
Yes.
Yeah?
Yes.
Alrighty. Okay, so let's go to the next one. Hopefully, let's keep going.
Wait, I have something to say.
Oh, good God. Yeah.
How do you expect us to write this down into the Google Classroom?
That's what I told her too,
I
right?
can't even write on it.
I print mine.
What you're
Print
going to
mine.
do is do it on a separate sheet of paper. And then submit that.
Well, I don't have a printer, Christian, so I have to do it by hand.
I'm going to pause the video real fast.
Bring ourselves
Why?
Because my thing was freezing up. Okay, actually, I think it's okay now. Yeah, it's not
Look,
all about you. I was having issues.
I just got a message from the AP exam. It was like, our AP exam's going to be easier this year? And yes, it is, because I'm cheating the whole way.
It's open note.
It's open note. Wait, I have a
White
question,
Sox is
Dr.
open note.
Tomari.
All right, so let's come back to this. We realize that I think we're still recording, so those of you who are talking about cheating, you might want to stop.
Talking about cheating.
I did.
Oh,
Okay.
Dr. Tomari, I have a question.
Yes, dear.
So are we gonna have a final for your class, or what are we doing?
There will be no final. My goal was to have each of my classes have one exam through the quarter, and you guys already took yours.
Yes. Okay.
So you guys are done with exams for me. You just keep doing the work and learn what you can, and we'll call it quits after that.
All right.
Okay?
Yes, ma'am.
All right. So back to this. Now we're looking at BH3. First thing we need to do is figure out the number of valence electrons for each of these. You're just going to count from left to right. All right, so how many does boron have?
3.
3. How many does hydrogen have?
1.
So we have 3 of those. So there's actually 4 there. So how many do we have total?
Dr. Tomari, that is not 4.
You're right.
That's
I added
3.
it. That's fine. All right, so it's 3 and 3. So how many do we have there?
6.
Wow.
So there's no charge. So from here, I need to figure out what's going to go in the middle. Will hydrogen ever go in the middle?
No.
No. So boron automatically has to go in the middle.
Do you have headphones? I need
What
headphones.
in the world is that?
What's going on?
Mercedes, is that your family?
No, not my family.
All right, so I have boron in the middle. Mina left. Bye, Mina.
I think it was her.
Yeah, me too.
All right,
My headphones. Okay, go ahead.
what do I do with the B and H?
You connect them with the line?
Connect them into the line. Equals a beautiful thing, ladies and gentlemen. Okay, how many electrons do I have here?
6.
6. How many do I have?
6.
6.
6. Okay, so I'm going to take a second to take a look at this. And I'm going to look at boron. Now, remember, hydrogen will never have more than 2, period. So hydrogen's automatically an exception to the octet rule because in order to be like a noble gas, it has to be like helium, which only has 2. If I look at boron, how many electrons does it have?
6.
6.
6. Is there any way in the world I'm ever going to make this have a full octet with this particular structure?
Can't you just put 2? No, never mind.
No.
No, I ran out of electrons. How can I have a full octet when I only have 6 electrons to begin with?
No, dude.
That's why this is an exception to the octet rule. It's because boron can only have 6. You guys follow that?
Yeah.
Yeah. Don't get brothers.
Okay, that makes no sense. But okay, does anybody have any questions on this one before I go forward?
No.
No? Are we good? Lucas, you all right?
I'm good.
Okay. All right. So now we're looking at PCl5. If I'm having a 4 there, I'm going to put a 5. I did not change any of this when I added these in. Okay. And this is supposed to be a P, not a Cl. All right. So let's figure out the valence electrons. How many valence electrons does phosphorus have?
5,
5. How many does chlorine have?
7,
7. What's 5 times 7? Because there's 5 chlorines.
5.
35. That 5 times 7, that 5 I was talking about, came from the chemical formula. I don't want you to confuse that. All right, so how many do I have total?
40.
What's going to go in the middle, the phosphorus or the chlorine?
Phosphorus.
How did you figure that out?
Because it has less numbers.
Okay, so there's a couple of different ways you can figure that out. One is that there's the less numbers. The official way, if you were ever quizzed on this,
It's because it's further away from fluorine.
can we have a little more enthusiasm?
It's further away from fluorine.
Further away from fluorine. I'm tired. I'm gonna fall asleep.
Then go take a nap.
All right, so
I mean, Lucas.
you don't even know who you're talking to. All right, so how many electrons are around phosphorus?
40. Wait, no, it's 10. Sorry.
There's 5 lines going to the 5 different chlorines. Each one of those lines are 2 electrons. So far we have 10 electrons used up. How many more do we have left?
30.
We have 30 that we have to deal with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No, 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 no.
See, that's just a lot of racing.
Okay, so there's my 30 electrons. Okay. You always start from the outside and you work your way in. Okay, so you do the outside atoms first. If it's hydrogen, there won't be any dots. But if it's another element, you can add it to that other element. So because all the chlorines have room there, I went ahead and I gave them all the lone pairs. All right, so we actually already used up all of our electrons at this point. All 40 of them are used up. Take a look at phosphorus.
It has more than 10, it has more than 8.
It has more than 8. This is called an expanded octet because it's more than 8. So this is, once again, an exception to the octet rule because there's more than 8. Is there any way that I could have had just 8?
No.
No, because we would have had to get rid of a chlorine, right?
Yeah.
That's just not feasible. That's why it's acceptable. All right. Is there any questions on this one?
No.
Nah.
All right. Do we feel pretty comfortable? Do you want to go to the resonance or do you want to go through the last one I have here, which is sulfate?
Yeah, let's do resonance.
Yeah.
I get sleepy.
I'm going to do sulfate, which is the next one I have on the list, which is the next one on your worksheet. And
Can you do the second resonance one too?
I think the second resonance is sulfate, isn't it?
The CO3 2 minus.
CO3 or CO4? Oh, carbonate. I'll do carbonate as well. All right. So why is this not? Okay, there it goes.
Mm.
I have like a huge delay. I think I'm having Wi-Fi issues. Okay. So when we're looking at this one, this is actually, I noticed on your worksheet, I told you to do sulfate as a Lewis dot structure. Then I turned around and told you to do it as a resonance. So I'm going to do it as a Lewis dot structure first. And then I'm going to carry this over to the resonance portion. Okay? Sound like a plan?
Yeah.
Yeah. Yay, chemistry.
Oh.
All right. So sulfur, how many valence electrons do we have?
God. Where is it at? I can't see it.
2, 3, 4, 5, 6.
6.
6. I said it for 6.
No, you did. I did.
Okay, oxygen, how many do we have?
6.
6. But we have 2 oxygen, so we actually have 12 there. How many do we have total?
18.
What was the question? 18.
18 electrons total. But then we have a -2. That -2 tells us to do what?
Add 2.
2.
Add 2 electrons, that's right. So we have 20 electrons we have to deal with. What's going to go in the middle, the sulfur or the oxygen?
Oxygen. No, sulfur, right?
Sulfur.
Correct. So 1 sulfur there, and then we have the 4 oxygens around it. Okay. So we have how many
Wait, I'm
electrons taken
confused.
care of? With what?
How many electrons are we supposed to have right now? Like, did you count up?
To begin with, we had 6 from sulfur and then 12. Oh, geez, that's supposed to be a 4, isn't it? 6 times 4 here.
Yeah, I was gonna say, shouldn't it be like in total 32?
Okay, so 24. Ah, crap. I'm sorry to confuse you. Okay, so for some reason I was putting a 2 there. I was looking at the -2 probably. Because of this SO4, I have to do 6 times 4 for the oxygen, which gives us 24.
Yeah.
And then 24 plus 6 is 30 for the total, plus another 2 is equal to 32. I messed up in class. Why should this be any different? It makes you feel more like real life, right?
That means
It's
you should
more
just give us the
realistic.
worksheet answer. You should just give us points for the worksheet, honestly, since you messed up.
All right, moving on.
Okay.
That's right.
Dang.
All right, so how many electrons do I have taken care of at this point?
8.
8. So I have 32 minus 8. So 32 minus 8 is what?
Oh my gosh.
24.
24.
All right, so that means I have to deal with those 24. All right, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 19, 20, 22. There's my 24. Is everything in octet? Did I count that right?
Oh no, wait. On where's Jamaria? Jamaria, answer.
Right here. I'm sorry. I'm distracted right now. You gotta give me a second. What was the question?
Is this right?
Yeah.
Is that what everybody else got?
Yeah.
Okay. All right, so the next one is the carbonate resonance.
Wait, so that was the resonance answer? It's the same thing as the Lewis dot?
Well, I'm looking at this and there is no resonance structure as I'm looking at it.
Oh.
Because either way, the structure is going to be the same. Unless I miscounted it.
No.
4, 6, 8. I'm going to pause it so that way I can recount it without having to worry about it.
Dude, Dr. Tom.
All right, so we're going to finish up with the resonance structure. If we look at this one, if we go back to the sulfate, in the previous video, I talked about formal charges, what they were bringing in versus what they were getting out of it. Do you guys remember watching that part? Did you
No,
watch
I
that
don't
part?
even think I've watched it, to be honest.
Okay, so when we talk about formal charges, we're talking about what they're getting in versus what they're getting out. Okay.
Okay.
So if we look at oxygen, how much is oxygen getting into the program, into the structure?
6.
6 oxygen is bringing in 6. So it brings 6 to the party. So right here, that's how we got that. That's the total valence electrons. Now, if I look at the oxygen structure right now, how many electrons if I take half of that bond? Because if I split it in half and give one to sulfur and one to oxygen, how many electrons is around oxygen right now?
If you gave one to oxygen and one to sulfur,
Yeah,
7.
it has 7. I'm talking about formal charges here. All right, so it has 7. Okay, but it only brought 6. So how many, what would be the charge if it has an extra electron there?
-1.
A -1. Do you see that, Mercedes?
Wait, what?
Okay, oxygen brought 6 electrons from the valence electrons. Right
Okay.
here. Okay. However, when it bonds to follow the octet, it now has 7 electrons.
Okay.
It has an extra electron.
Right.
Because it has an extra electron, it has a -1 charge.
Okay.
You follow that?
Yeah.
And I can say this is a -1 for the same reason.
Mhm.
And this is a -1 for the same reason.
They're all -1.
They are all -1 right now. And if I look at it and I start looking at sulfur right in the middle here, how many electrons does it have if it only has 1 from each bond?
4.
4.
4. How many does sulfur bring?
6.
6. So sulfur brought 6, but it only has 4. So what's its charge?
-2.
Is it -2 or is it +2?
+2.
It's +2 because it's missing 2 of its electrons.
Okay.
This does not follow the proper formal charge because we have formal charges everywhere in this situation. Okay, every single element in here has a formal charge on it, when really the goal is to maximize the zeros. We're trying to minimize that formal charge. So if we start thinking about it in that way, what's the easiest way to give that +2, get rid of that?
Ask that again.
If it has a +2, in order to make it a 0, what does it need?
In order to make
-2.
If it has a +2, it's -2 electrons.
Mhm.
To make it a 0, what does it have to do to make that a 0? This is the tough part.
Go ahead, Lucas. You can answer this question.
So you're trying to get sulfur to 0 electrons, correct?
Yeah. So I'm going
So
to write this. We're trying to get everything to 0. Right now, everything it has a charge. This is a -1. This is a -1. This is a -1. And this one has a -1. Sulfur has a +2. You follow me? If I'm trying to minimize it, so I'm trying to give away some of oxygen's electrons, but sulfur wants to take some electrons. I can take these electrons here and I can share them. I can make that a double bond.
I was about to say that.
Okay? And so that means that this one would go down to a +1 and this would go down to a 0. I could do that again on the other side, couldn't I?
Yeah.
I could make this electrons and I could take that over here. Once again, that would turn this into a 0. And now this is a 0. Ultimately, what that means is I have 2 double bonds in this structure. I hope the other 2 actually pay attention to this video later because I figured out my issue. -1, -1. Now it's still a -2 charge. Is sulfur obeying the octet?
Yeah.
Is it?
Wait, no, it's
No.
not. It's not.
It's not. It has 10 electrons, or does it have 10 or 8? 2, 4, 6, 8,
12.
10, 12 electrons around it. So technically, it's like way beyond the octet. However, because it's minimizing the formal charge, it can do that. All right, so if I take this over to the resonance structure, okay, so we did the Lewis dot structure on one side. If we do the next worksheet and do the resonance structure, you can say, all right, we determined this to minimize the formal charge. But once again, those electrons don't necessarily have to be there. Instead of doing it from the left to right, I could let these electrons go back and then let these electrons come down. So I can have this resonance here of it being on the top and bottom instead of the left to right, because it doesn't matter which 2 electrons I take. Okay. I still have a formal charge here and formal charge here, but the other 3 are zeros still. That's what's making it a resonance, is that we didn't change the actual order of things, but we moved the electrons around to try to help minimize the formal charges. Does that make sense?
Yep.
Mercedes, how you feel?
Yeah.
Okay. Let's try another one. The carbonate. What is carbonate?
Is that C3H5?
No, that's the next one. I can do that too if you want. CO3 2 minus is carbonate. This is the one in particular that Mercedes was asking.
That's the first one.
All right. It's the first one, right?
Yeah.
Okay. All right. So how many electrons does carbon bring?
Carbon has
4.
4 is correct.
4.
How about oxygen?
6.
6.
6, but we have 3 of them.
Times
So
3.
Times 3. 18.
So what's 18 plus 4?
22.
But then we have this -2 charge up here. So what does that do?
Add 2, 24.
Add 2 to make 24. All right. So from here, we have carbon in the middle, and then we have the oxygens around it. We're going to bond those together. All right. How many electrons do I have spent so far?
6.
So
6.
24 minus 6.
18.
18. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. That's supposed to be 1. All right. Now that we got to this point, let's look at our octet rule. Do you see an issue? Either of you. Where does the octet issue lie? Is oxygen a full octet?
Yes.
Is carbon a full octet?
No.
No. How many electrons does carbon have right now?
6.
Mercedes, do you see how carbon only has 6 here? Mercedes, you still with us? Okay, she just sent me a message saying that she lost her connection. So hopefully she'll log back in. All right, so it's just me and you, Lucas.
All
All
right.
right, so there's only 6. So to alleviate this issue, we can take those 2 electrons and we can share them over to make it a double bond. You see that?
Yeah.
So carbon can now have a double bonded oxygen there. And then we can go back and put in our lone pairs. Okay, so now everybody has a full octet, right?
Yeah.
All right, so let's take a look at the next issue. And that next issue is formal charges. What's the formal charge on this top oxygen here?
7.
Okay, it has 7 electrons. It brought 6 to the party. What's its charge?
It would be -1, right?
-1. How about this one here?
Same thing, -1.
How about this one here?
That would be 6.
So it brought 6 and it has 6.
So that'd be
What's
0.
its charge? It would be 0. How about carbon?
Carbon has 4.
And it brought 4.
So that's 0.
So that's 0. Is there any way we can minimize this? Do you have any positives and negatives that we can cancel out?
No.
No. Because of that, that's going to be our most stable structure. Right, I'm going to erase this so that way I have more room to write.
Okay.
All right, so carbon is in the middle. Double bonded oxygen. Oxygen, that's what we just figured out, right?
Yep.
And that has a formal charge of -1 and -1. -1 and -1. Now, when I'm looking at this, did I have to put my double bond here, or could I put it elsewhere?
You could have put it at either of the other ones.
I could have put it at either of the other ones. Because of that, that means I have a resonance. So the carbon is here. I could have brought it up from the top. The carbon's in the middle. I could have brought it up from the right. Okay, so those are my 3 resonances, assuming that you put in all the dots around it and whatnot in the
Yeah.
charges. But that's how you determine resonance. Do you want to try the one with the C3H8 or C3H5, I think?
Yeah.
That was a little bit harder, so that's what I was asking.
Let's do that one.
Okay.
3, 5, 6, 4. So 4 times. Carbon would have 12, and each would have 5. 16.
My screen to connect. All right. All right, so C3H5 with the +1 charge, right? All right, so how many does carbon have?
Carbon has 4, but times that by 3, it's 12.
Okay, and hydrogen has,
1, but it would be 5 because you have to times it by 5.
and then so that gives us 17, but we have a +1 charge, so what does that give us?
-1 to make it 16.
16. So I have 16 electrons to deal with. Will hydrogen ever be in the middle?
Huh?
Will hydrogen ever be in the middle?
No.
No. That means carbon's going to be in the middle. I'm going to put carbon, carbon, carbon. Those are my 3 carbons. Now with the rest of the hydrogens, I'm going to distribute them as evenly as I can. 2, 3, 4, 5. Okay. So when I'm looking at this structure, I have 2, 4, 6, 8, 10, 12, 14 electrons used. You see that?
Yep.
Okay. How many more electrons do I have to deal with?
2.
2. All right. Will they ever go on hydrogen?
Huh?
Will extra electrons ever go on hydrogen?
No, it would go with the middle carbon.
Okay, we can put it on the middle carbon here. From here, let's take a look at octet rules. All right, so if I look at this carbon here, how many electrons does it have?
6.
6 electrons. How about this one?
6.
Okay, how about the one in the middle?
8.
So that one in the middle is the only one that actually follows the octet rule at this point. Okay? We
Yeah.
also have a +1 charge to deal with. Okay, so am I going to make everybody happy here? If I have
You wouldn't be able to.
no, not really, right? So these 2 electrons can either go to the left or it can go to the right. I'm going to make it go to the right first. And what does that do? It creates a
Would
what?
that make that one a double bond towards the other carbon?
Okay, that would make a double bond towards the other carbon. This is getting cluttered, so let me erase some of it soon. All right, so as we're looking at this, let me erase the stuff on top so that way it's less cluttered. All right, as I'm looking at this, is the carbon on the right, does that have a full octet now?
Yeah.
The carbon in the middle, oops, I forgot hydrogen here. Is the carbon in the middle, is that a full octet?
Yes.
The carbon on the left, is that one?
No.
Is there anything I can do about it?
No.
Not really, because I don't have any more electrons to spread around. All right, so let's look at formal charges. For this carbon here on the right, what's its formal charge? How many electrons does it have on around it right now?
Right?
Huh?
Would it have 4?
It has 4 around it right now. How many did it bring to the party?
It brought 4?
4. So it has 4. It brought 4. So what's its formal charge?
0.
0. How about here in the middle?
That charge would be 0 because it brought 4 and has 4.
How about this one right here on the left?
It's 3, so it'd be -1, or would it be a +1?
It has 1 less electron than it's supposed to.
So, +1?
+1. So that's going to be where our formal charge is. So that +1 exists on this carbon here. Do you follow that?
Yeah.
Okay, so could that double bond have been put on the other side?
Yes.
So that is where the resonance comes in. You're sounding pretty confident about this now. Where's that formal charge going to be this time?
It's going to be on the right one.
There's my formal charge. How do you feel about this?
Okay.
Doing okay? All right, do you think you can finish this up for the last 5 questions? I did basically half of the worksheet for you.
I only have one. I've done this earlier. But yeah.